Our focus today is on special angle pairs. In particular, there are three of them that we're really concerned with, and that will play a significant role for us throughout our study of geometry. We need to know what vertical angles are, what complementary angles are, and what supplementary angles are. We have to be able to recognize them in a picture, and based on our pictures or a verbal description, a written description, we need to be able to figure out how big they are. That's our focus today. What are vertical, complementary, and supplementary angles? How do you recognize them, and how do you figure out how big they are? And so we'll start off with our vocabulary. And note that a lot of angles have special relationships between them. There are just certain characteristics that if you spot them, they are clues that there are more information that you can get right away. Pairs of angles frequently have those types of relationships. Just in a general English sense, what does the word adjacent mean? At its most basic level in English, the word adjacent simply means next to. Things are adjacent if they're next to each other. So your next door neighbor, their house is adjacent to yours. The person whose desk is right next to you, they're adjacent to you. Understanding that the word adjacent just means next to, what are adjacent angles? They're angles that are next to each other. Now, one piece I'd like to caution you about, this piece that I'm drawing in blue is not considered, I'll change colors on me. This is not considered an adjacent angle. Why not? Because they look like they're next to each other. The one defining characteristic that we require for adjacent angles is that they must have a common vertex. In terms of our context, this would be like driving down the street to a neighbor down the street and saying, are they right next to your house? No, they're a little bit ways down the street, and so we wouldn't call them adjacent. Adjacent angles must share a common vertex. And because they share a common vertex, they are also going to wind up having a side in common, so that they're next to each other. A linear pair is a special type of adjacent angles. Just looking at our picture, we have a pair of angles, and I really like this one because what does the word mean right there? Linear. Tells us exactly what it looks like. Linear means a line. Pair. So we have a pair of angles that make a line. That's it. All right, so let's look at these pair of angles. Angle AEB and angle BED. Are they adjacent? Are they adjacent in a linear pair? Or are they not adjacent at all? What do you think? Remember how we identify them in order. A connects to E, connects to B, and we also have B connects to E, connects to D. With that yellow and blue pair of angles, are they adjacent? Yes, they are. These are adjacent angles. Are they adjacent and forming a linear pair? Yes, they are creating a line along the bottom, and so we can then recognize, well, I didn't, that one far enough, there. They are adjacent angles and they form a linear pair. What about these two? AEB and BEC. AEB, BEC. Are they adjacent? Yes. They're right next to each other. They're sharing this side BE. Do they form a linear pair? No. So they're only adjacent. And lastly, angle DEC, DEC, AEB. We'll note, of course, that they are sharing the same vertex. We do have to have a common vertex for adjacent angles. But would you describe those as adjacent? No, these are not adjacent because they don't share a side. Adjacent angles need to have the side matching up and actually sharing it together. It's like the walls of an apartment building to be adjacent. So these are not adjacent at all. And here's our last example pertaining to these, with something slightly more complex. What about angles 5 and 6? What kind are they? We've got 5 and 6. Those do form a linear pair. Now, two special pairs of angles are complementary and supplementary. Complementary angles, if we measure them out with a protractor, they will add up to 90 degrees. Supplementary angles, if we measure them out, will add up to 180 degrees. Please notice, they do not have to be adjacent. We can have a 60-degree angle in the room and a 30-degree angle in Taiwan. Those are still complementary angles because 60 plus 30 equals 90. It is common in picture form to have two angles that will create a 90 degrees as a linear pair. And so it's common to see them as an adjacent pair. This set in red, angles 1 and 2, would be complementary. But you don't have to have them next to each other to be considered complementary. Those same angles separated are still complementary angles, because if we put the numbers on them, like 53 and 37, what do you add up and get? That makes them complementary. If they add up to 89, no, not complementary. If they add up to 89.8, not complementary. They have to add up to exactly 90. And we have the same type of thing going on with supplementary angles. If we draw supplementary angles adjacent to each other, they will form a linear pair. Because we know a straight angle is 180 degrees. But they don't have to be together. It is acceptable for them to be separated. For instance, angles A and C. If we add them up, we still get that 180, and even though angles A and C are not touching each other at all, they're not adjacent, they're still supplementary. Sometimes students think that complementary and supplementary angles have to be adjacent. That's not accurate. Let's say I have a 35-degree angle. How big is its complement? That is, how big is the other angle that would get you up to 90? All you have to do is subtract off the first angle, and you get the complement. It would be 55. And we can do this with variables as well. Let's say I have an angle that is x plus 40 degrees. How big is its complement? It's not going to be 50. It would be 50 if the angle were 40 degrees. But it's not just 40, it's x plus 40. We will follow the exact same thing that we did before. In this first example, we simply took 90, subtract off the 35. So we took 90 minus our angle. We'll do the same thing. 90 minus the angle. And that looks like our warm-ups. We know that we would have to subtract across the parentheses 90 minus x and minus the 40. So combined, 90 minus 40 is 50. And so our answer is 50 minus x degrees. Supplementary angles work the exact same way. If we were to take this 35 degrees again from the original, how big is its supplement? Supplement adds up to 180, so to get the supplement, we'd just have to subtract off from 180, which equals 145. Just like before, if we wanted the supplement for x plus 40, we would have to subtract it off from 180. So 180 minus that x plus 40, exactly like we were doing before, we need to subtract across the parentheses, subtract x, subtract 40, and then we can combine the numbers. 180 subtract 40 is 140. And we have our supplementary angle. All right, so let's consider these then. How can we use a complement or a supplement to solve a problem? Essentially, this is saying, how could we create the equation? All right, so looking through it. An angle is 10 degrees more than 3 times the measure of its complement. Find the measure of the complement. Okay, so how can we start putting these pieces together? Do you remember solving systems of equations in Algebra 1? We could create a system of equations here. In particular, since we're looking at complementary angles, what is the fact that we know about complementary angles? What do they add up to? So we can use that as we can use that to create an equation. An angle plus an angle will add up to 90 because they're complementary. All right, then we can also say an angle is, so Here, I'll change the color on this one. An angle is 10 degrees more, and now I'm going to leave this word then alone because we know then is going to flip it around, 3 times its complement. We're just reading it step by step, writing down what we're reading. Because of the presence of this word then, we know that this piece actually needs to get flipped around. And so we then have 2 equations to work with. So that moved on. All right, leave that alone. Well, where can we put these 2 pieces together then? I wrote down that wrong number. That was not an A, that was a 10. Well, we can easily do substitution then here. Right here we have A, and we have A equals. This blob of stuff is the same as our angle. So using the substitution technique from Algebra 1, we'll just plug it right in. That would give us 3b plus 10 for angle A plus angle B, and they will add up to a total of 90. Noting that this particular problem is based heavily on 2 sets of skills. Your ability to read through the problem and create those equations, knowing what complementary means to get the original equation in the purple, being able to read through the description to get that equation in the yellow, recognizing those equations is one set of skill. The second is, do you know how to solve a system of equations, which was one of the critical things for you to take out of Algebra 1. Now we can go through and solve it. 3b plus b is equal to 4b. We can subtract 10, giving us 4b equals 80. And when we divide by 4, we get the value of b is 20. So one angle is 20. And so if one angle is 20, how much is the complement? How much more do you need to get back to 90? 70. So that would tell us A is equal to 70. We have our pairs of angles. They've got to be 20 and 70. The last piece that we need to have are vertical angles. Vertical angles are angles that are across from each other. For instance, this angle number 2 is across from angle number 4. Those are vertical. Angle 1 is across from angle 3. Those are vertical angles. So give me a pair of vertical angles here. Well, let's start by just naming one angle. Pick any angle you want. Okay, that'll work. We could say angle HMJ. HMJ. Which one is vertical to that? Right along the bottom. So angle LMK. We have vertical angles. We're done. One of the key characteristics behind vertical angles, and and we'll discuss this moving forward to the future, vertical angles will always be congruent. So for instance, if this were a 40-degree angle on the left, its vertical angle would have to match in size. We will discuss that fact more later on.